The most distant human-made object, NASA's Voyager 1 spacecraft, is in interstellar space. Two spacecraft outside of our pale blue dot have made groundbreaking findings and consistently illuminated the planet both inside and outside of our system. The explorers have traveled throughout the whole solar system, exploring previously unexplored regions of the vast, starless emptiness. Scientists are pressing the alarm button after seeing something amazing today. What have they discovered? Then, what prospects does space exploration have? Come see what Voyager discovered at the solar system's boundary that surprises NASA. The start of history. Without examining the Voyager's origins, it is hard to discuss their significance in an era characterized by rapid technological development and groundbreaking scientific discoveries. NASA charted a new trajectory that altered our understanding of space. Two golden spacecraft, each around the size of a small bus, were developed in 1977 with the goal of expanding human knowledge outside of our atmosphere. The longest road trip in human history was about to begin for these twin explorers, Voyager 1 and Voyager 2. As scientists and engineers completed the Voyager spacecraft, the excitement at NASA was evident. In addition to being aesthetically pleasing, their slender bodies shone with gold to shield their fragile instruments from the harsh environment of space. In order to solve the secrets of our solar system, Voyager 1 and Voyager 2 were equipped with a variety of cameras, spectrometers, and other scientific tools. The initial idea was straightforward: a brief 5-year run past Jupiter and Saturn to gather data and take pictures. However, these daring spaceships had different plans. After flying by Saturn's breathtaking rings and Jupiter's whirling storms, Voyager 2 rose to fame in the cosmos. It proceeded to visit Uranus and Neptune, two frozen giants, becoming the first spacecraft to do so. Scientists were amazed by the images it returned. Neptune's violent black storms in 1989 and Uranus's bent rings in 1986 revealed to us places we could only imagine. An even greater goal was the aim of Voyager 1. This tireless explorer burst through the bubble of our solar system and into interstellar space in August 2012, something no human-made object has ever done before. Imagine it as stepping out of your backyard and into an uncharted wilderness. Scientists were so taken aback that they double-checked their data for a full year before making this historic announcement in 2013. These spacecraft contained the most cutting-edge technology available at the time, which made them genuinely unique. In addition to instrumentation that could measure anything from magnetic fields to microscopic particles in space, each Voyager had greater processing capability than the first personal computers of the 1970s. Most impressively, they were made to withstand radiation levels that might quickly damage a smartphone and temperatures cold enough to freeze nitrogen. Numerous surprises have come to light during their travels. They found the first active volcanoes we had ever observed outside of Earth on Jupiter's moon Io. They detected solar winds that no one even knew existed, discovered odd spokes in Saturn's rings that shouldn't be there, and discovered unidentified rings surrounding Jupiter. When the internet was merely a pipe dream, most phones still had rotary dials, and digital watches were the latest technological advancements. These spacecraft were constructed. Nevertheless, they continue to function, continue to return data, and continue to provide us with new insights into our cosmic neighborhood. As humanity's most distant creation to date, Voyager 1 is in the lead, with its duplicate trailing closely behind. Together, they have transformed astronomy textbooks, unraveled long-standing space riddles, and helped us realize how vast and magnificent our solar system really is. Their radio signals, traveling at the speed of light, now take more than 22 hours to reach Earth, since they have traveled so far, and they are still traveling. What started off as a small 5-year expedition has grown into the biggest space adventure in human history, a 45-year odyssey that has permanently altered our perception of our place in the cosmos. The question then becomes, How can they connect with Earth from such a great distance? Let's investigate the system of communication. A beautiful dish antenna is the foundation of Voyager 1's communication system. Voyager 1's dish is more than a meter wide, in contrast to the small ones employed by residential satellite systems. It is sensitive due to its size, and it is extremely directional due to its tightly regulated shape. The high-gain antenna could actually cover an area about half the size of Pennsylvania if it were pointed at a target on Earth. The Voyager 1 spacecraft uses two distinct radio frequencies, 2.3 GHz and 8.4 GHz, to transmit communications to Earth. The message must be transmitted at a slightly lower frequency, 2.1 GHz, when Voyager 1 gets it from Earth. These are very effective frequencies in the vacuum of space. They are optimized to be even more effective than the Apollo astronauts' trusty space radio. The signals that the spacecraft transmits begin as a meager 20-watt emission, which is equivalent to a standard refrigerator light bulb. These messages have become the most insignificant of waves, far less energetic than a whisper in a silent room. By the time they reach our planet, however, NASA's massive missile dishes, which are 230 feet wide, can still pick up what is essentially gibberish coming from the Voyager spacecraft. Voyager 1 contains a digital tape recorder with a capacity of about 67 megabytes. To fill the massive gap, that would be enough to carry roughly 15 songs on an average phone. However, until you play the type of music found on the golden record, music cannot truly help us grasp who we are and where we're from. Voyager 1 is probably the most remote tape player in existence because it is still operational and sends data back from a distance of more than 13 billion miles. Each signal from Voyager 1 takes more than 22 hours to reach Earth, which is enough time to make 2 trips around the planet. The Mars rovers, in contrast, can ping Earth and receive a response in a quick 15 minutes. The modest exchanges that keep this spacecraft, the furthest from home, connected to its builders, require patience and timing, which are required for every communication with Voyager 1. This cosmic discussion relies on NASA's Deep Space Network. The network contains what could be regarded as the solar system's 2 best ears. Antennas make up these ears. There are 2 different kinds of antennas, the 230-foot diameter antenna and the 112-foot diameter antenna. The 2 types of antennas together are sensitive enough to detect signals 1,000 times weaker than what a human could hear with a local FM radio station. These detectors are now so sensitive, thanks to modern technology, that they might theoretically catch signals from space probes located many light years distant if the signals weren't somehow enhanced to an energy level several times higher than what we currently receive from Voyager 1 and 2. The key question is whether they could accomplish this. Astute power management is necessary to keep Voyager 1 connected to Earth. The spacecraft uses nuclear batteries known as radioisotope thermoelectric generators, RTGs, to produce its electrical energy. An RTG just continues to operate until it runs out of usable power, much like a regular flashlight dims before giving up. But unlike a regular battery that eventually gives up the ghost and stops working, these power sources gradually lose power. When Voyager 1 was launched, its 470-watt power source was sufficient to fully illuminate 4 incandescent light bulbs. Today, the spacecraft runs on less than 300 watts despite less sunlight. However, even that figure is deceptive since the heaters that maintain some of Voyager's fragile electronics utilize electricity that is dangerously close to the 300-watt limit when combined with the power needed by the operational instruments. The command team's first task is power management. Despite these efforts to save energy, Voyager 1's supply is still dropping at a rate of roughly 4 watts annually. The mission's engineers must constantly devise new strategies to increase the remaining power and, most crucially, to sustain the connection with Earth. Because of this gradual decline, their pioneers have accomplished a great deal, thanks to their sophisticated communication networks. The accomplishments of the explorers. Voyager 1 has continued to travel since its inception and is currently 14.6 billion kilometers from Earth as of August 2012. At the moment, it is traveling across space at an incredible 17 kilometers per second. Voyager 1 continued to travel at an incredible speed after entering space in the strange realm of interstellar space. Voyager 1 is our sight and sound here in what is essentially a micro-graveyard for the solar system. It is returning data on things we never thought existed, strange data, inexplicable magnetic fields, and what scientists are referring to as plasma tsunami waves. A peculiar type of cosmic rays that shouldn't exist are being returned by the still operational Voyager 1. We are learning more about what is beyond our heliosphere, about the extreme edge of the solar system, and about the interstellar medium. As Voyager 1 gets further away from our solar system and its planets, Voyager 1's surroundings are not what we expected. It is a mixture of various charged particles that were left over from star explosions that happened millions of years ago. Rather than being a vacuum, we are only now starting to understand the stories these particles tell of dramatic and turbulent cosmic events. Perhaps the most significant discovery made by Voyager 1 was concerning our solar system. Returning to its current location, it is providing us with a view of the heliosphere, a massive bubble created by the solar wind that our sun emits. The spacecraft has shown that the pressure of interstellar space causes this bubble to be compressed and dented. Rather than being a perfect sphere, its surface is a wavy, uneven sheet. It dips downward toward the closest star, Proxima Centauri, and bulges somewhat in the direction our solar system is moving through the galaxy. But we are only at one end of its vast surface area. Despite being relatively close to us, the next solar system has a half-billion-year history. Even though Voyager 1 has been working for an exceptionally long time, long as many of its engineers have been alive, it doesn't show any symptoms of aging. Every second, it's traveling another 17 kilometers into the vast unknown, further and deeper into the deep annals of space, and therefore establishing its position in the cosmic history of humanity. In some way, each signal it returns makes itself increasingly more important, a new turning point in the history of human frontier exploration. So, have you ever pondered how a device constructed in the 1970s manages to remain flawless in the most hostile environment imaginable? Let's examine the specifics. A marvel of engineering, the Voyagers are among the most durable spacecraft ever constructed by humans. They are not your typical spaceship. Building anything that is meant to withstand the toughest environment in the cosmos requires a great deal of effort and consideration. First, let's talk about power. The engineers of the Voyagers recognized that solar panels, which are used in most spacecraft, would not function in the darkness outside of Saturn. Instead, they gave it 3 nuclear batteries called RTGs. The same process that keeps the Earth's core hot is used in these incredible power plants to generate electricity from the decaying plutonium. The initial power output of each RTG was 470 watts, which is roughly equivalent to 4 brilliant light bulbs. However, Voyager 1's handling of the harsh conditions of deep space demonstrates its true genius. Special gold foil that reflects heat and radiation is used to wrap its outer shell. Inside, it features 3 different computers that can check each other's work. The others notice if one makes a mistake. That's more sophisticated than a lot of modern aircraft. The brain of the spaceship is quite effective. It uses 64 kilobytes of memory, which is less than one contemporary digital picture. Nevertheless, this tiny computer keeps its antenna pointing toward Earth all the time while controlling 11 distinct scientific instruments. It's similar to balancing on one foot, playing chess, and solving math problems simultaneously. In relation to instruments, each one is an engineering marvel. Single atoms flying across space can be detected by the cosmic ray detector. A refrigerator magnet might be detected from a mile away by the magnetometer. Due to its extreme sensitivity, particles so thin that their combined ions would weigh less than a snowflake are measured by the plasma sensor. The communication system aboard Voyager is the main attraction. Its main antenna, which is almost as wide as a tennis court, can pick up radio signals that are as weak as a snowflake falling. Massive dishes in NASA's Deep Space Network, including one in California taller than a 20-story skyscraper, receive these signals when they reach Earth. Voyager 1 was constructed with longevity in mind. There are backup mechanisms for it. Its wiring is sufficiently robust to withstand micrometeorite strikes. Its computer code is also constructed in a unique fashion that allows it to continue operating even in the event that some of its memory fails. Even spare copies of critical systems that could be turned on decades later were considered by the engineers who designed it. The ability of Voyager 1's engineering to adjust to issues, however, may be its most remarkable feature. It simply switched to backup thrusters that hadn't been utilized since 1977, when its primary thrusters, which had been in use for 40 years, started to wear out. Voyager 1 continues its journey today, bringing with it the pinnacle of human ingenuity from the 1970s. How did NASA's Voyager spacecraft steer clear of asteroids and black holes? Voyager 1 and Voyager 2 have traversed billions of kilometers of space since their launch to investigate the outer heliosphere and the solar system's periphery. However, the fact that they have not encountered catastrophic occurrences like asteroids and black holes during their extensive trek through this immense expanse of space is among the most enigmatic aspects of it. The intelligence and diligence of NASA's scientists and engineers are responsible for this outstanding achievement. The size of space and the many dangers it contains must be taken into account in order to appreciate the difficulty of this accomplishment. There are millions of asteroids, comets, and other objects in the universe, and many of them are fatal risks to spacecraft. Additionally, black holes are fascinating because of their powerful gravitational pull, which can draw anything that dares to approach. How, therefore, did NASA accomplish this outstanding achievement? The utilization of particular design solutions, precise computations, and thorough preparation are the keys to the solution. As with every launch, NASA scientists calculated the Voyager spacecraft's paths in a way that would assure they would not run into black holes and asteroids. Based on the known structure of the galaxy and the location of asteroids, engineers designed a path that would lead the spacecraft past less populated regions of space. Additionally, gravitational slingshots helped with maneuvers, which were crucial to the Voyager expedition. The spacecraft passed near both Jupiter and Saturn at a right angle, changing course and gaining velocity from the gravitational pull of these planets. NASA scientists were able to ascertain the gravitational pull that these formations exerted and ensure that their vehicle would not be in an unfavorable orbit. Thanks to this technique, the effectiveness and skill of NASA engineers are demonstrated by the fact that all of these gravitational slingshots were accomplished. Another element that was essential to the Voyager spacecraft's mission was asteroid avoidance. NASA took the following actions to lessen this risk. Conjunction analysis made it feasible to calculate potential collisions and stand the estimated asteroid approach. Controlling position made it possible to keep a safe distance from the asteroids in dangerous orbits. In this particular mode, NASA's Deep Space Network monitored the spacecraft's position and velocity data in real time, allowing for quick corrections if necessary. For the Voyager spacecraft, black holes posed a much greater threat. NASA used astrometry, gravitational wave sensing, and X-ray and gamma-ray monitoring to detect and avoid such cosmic occurrences. Space telescopes like LIGO and other gravitational effect tools also played a key role.